So good morning students. So in the last class we discussed about the types, nomenclature of alcohols, phenols, aldehydes, ketones and carboxylic acids, okay, ethers, haloalkanes, haloaryls and amines, okay. So from today's class we are going to discuss with the another one important topic, that is classification of the organic compounds what we studied before, okay. What are we studying? Haloalkanes, haloaryls, alcohols, phenols and ethers. Okay, and next aldehydes, ketones, and carboxylic acid, and also amines. So let's discuss the classification one by one. Classification of haloalkanes. Haloaryls classification is not there. Okay, haloaryls, right? Alcohols, phenols. Classification of haloalkane, haloaryle, alcohol, phenol, ether, aldehyde, ketone, carboxylic acid, and amine. Okay? All the classification I will explain in a simple manner for you people to understand. So, listen. In alcohols and alcohols, especially, a type of classification, both are same. Okay? So, students, the first one is based on nature of carbon atom. Based on nature of carbon atom. Which one? Haloalkanes. Based on nature of carbon atom. Okay? So in this haloalkanes, the first one type is based on nature of carbon atom. So first one type is primary, secondary and tertiary. How? So listen, if any haloalkane is there, RX compound, so otherwise I take, listen, CH3X I will take, this is alkyl group. So among this, if one is attached to, I write simply like this, CHHH. This one is what? H. Same I will take. For your convenience I am writing, okay? Okay? So we know that CH3X group, that is CH3X. This is alkyl halide. No doubt in that. So students, if any one of the hydrogen atom is replaced by R group, means the halogen or the carbon to which halogen is attached, which is further attached to one R group. Carbon to which halogen is attached, which is further attached to one R group, that is primary alkyl halide. Okay, next, if two hydrogens are means the carbon where the halogen is attached, the same carbon further attached to two R groups, then it is secondary alkyl halide. Okay, next here. So if all the hydrogens are replaced by R group, means this is the carbon where the halogen is attached and the same carbon is further attached to 3 carbon. Then it is tertiary alkyl halide. So that is alkyl halide, primary alkyl halide, secondary alkyl halide, and tertiary alkyl halide. And why I am considering this? Based on the nature of carbon atom. So here all the carbon atoms are sp3 hybridized. First step, based on sp3 hybridization, they are classified as directly. If halogen is directly bonded to the sp3 hybridized carbon atom, which is directly bonded to sp3 hybridized carbon atom, that is primary, secondary, and tertiary alkyl halides. So another one is allylic and benzylic. Okay, so listen. Allylic means halogen is attached to, of course, and right here, halogen is attached to sp3 hybridized carbon atom, but this carbon atom is attached to sp2 hybridized carbon atom. This is what? Allylic. Halogen is attached to sp3 hybridized carbon. But this sp3 hybridized carbon atom attached to sp2 hybridized carbon. If it is an aliphatic compound, then it is said to be allylic. So if you take this benzene ring, so in this benzene ring, all are sp2 hybridized. So next, if it is like this CH2X, so this halogen is attached to sp3 hybridized carbon atom, which is further attached to sp2 hybridized carbon atom. But the thing here is, this is the benzene ring. So another classification is benzylic. Means, so based on sp3 hybridized carbon atom, so these are classified as primary, secondary, tertiary, allylic, and benzylic. Okay, the stability order of this is benzylic greater than allylic, greater than tertiary, greater than secondary, greater than primary. For what? Carbocation and free radical. Both. It is just reverse for carbon. And again, the first classification is based on nature of carbon atom. In that sp3 hybridized carbon atom. How they are classified? One is primary, secondary, tertiary, allylic, benzylic. Okay. So the next one is okay. So the next one is sp2 hybridized carbon. One is vinyl halide. Another one is allyl. So what is vinyl halide? Directly I say, if the halogen is attached to, if the halogen is directly attached to sp2 hybridized carbon atom. So this is amine. If it is CH2 double bond CH single bond CH2X, this is allylic. Means if this is attached to sp3 hybridized, further attached to sp2. When this halogen is directly attached to sp2, when this is the aliphatic compound, means the straight chain other than aromatic or other than benzene ring, then it is vinyl. If it is benzene ring, of course all are sp2 hybridized here. It is like this, then this is allyl halide. Okay, so this is all about what? Okay, so this is all about classification with respect to sp2 hybridized. allyl, this is allyl. So this is vinyl, this is allyl. This is just a classification. I am not telling, this is not a nomenclature. Are you getting? This is simply a classification. The name of this is, so this is ethene allyl. Ethene or alloethene. That is the name of the compound. I am telling only classification, not the nomenclature. Okay? So this is one. What? So the based on the nature of halogen atoms, sorry, or attached to which type of carbon. And another one is that based on number of halogen atoms. So if one halogen is there, that is said to be mono. Two halogens are there, like this, di. Three, tri. Four, tetra. So based on the number of halogen atoms also, they are classified as mono, di, tri, tetra, etc. This is what are aliphatic compounds. So I write once again clearly for haloalkanes, and the same will follows for alcohols also. Listen, first one, based on nature of carbon atom. That the first one is sp3 hybridized carbon atom. Okay, so the first one is, sorry, I write directly RCH2X, that is primary alkyl halide. Next, RCHRX, secondary alkyl halide. Next, RCRRX, that is tertiary alkyl halide. Why it is said like that? Because if carbon atom is attached to only one carbon, only one R group, then it is primary. Carbon is further attached to 2 R, secondary. Carbon which is further attached to 3 R group, that is tertiary. That is the some rule. They are already identified. Next, so this is the first type. Next, another one, primary, secondary, tertiary we did. Another one is allylic. That is CH2 double bond CH single bond CH2X. This is sp3 hybridized. This is sp2 hybridized. Allylic. Next, benzalic halide. That is the benzene ring. That is sp2 hybridized, to which sp2 hybridized carbon atom is added, and this is the X. So these are the classification based on what? sp3 hybridized carbon atom, that is allylic and benzalic halide. Next, based on sp2 hybridized carbon atom. Based on sp2 hybridized carbon atom. So in this what happens? Listen, this is the example: CH2 double bond CH single bond X. Okay, one is vinyl halide, that is CH2 double bond CH X. I am not telling this is only the vinyl halide. Listen here, CH3 CH double bond CHX. This is also vinyl halide. Okay, next CH3 double bond CHX. This is also vinyl halide. Okay, that means in the place of this you can take here CH3, here X. This is also vinyl halide because the halogen is attached to the sp2 hybridized carbon atom. but the name of the compound is different, classification is different. So simple classification I am giving if the halogen is attached to sp2 hybridized. So the next one is amine. If the sp2 hybridized carbon atom is a benzene ring, so then it is said to be a allyl. No doubt. This is two classifications. So right here only. So another one is there, students, classification. The third one, based on number of halogen atom. For example, if it is like this, R CH2X, RCH2X, that is mono haloalkane, or simply we take haloalkane. If it is R CHXX, dihaloalkane. Okay, next here it is C H H R. Then it is trihaloalkane. If it is CH2X, CHX, CHX, CH2X, of course tetrahaloalkane. Like that. So based on the number of halogen atoms, one is their mono, 2 di, 3 tri, 4 tetra. Similarly, 5, 6, 7, 8, 9, the classification goes on. So another one, students, the same, the based on the halogen atom, another one classification is there. So one is geminal halide, another one is vicinal. Okay, so one is geminal halide, another one is vicinal halide. Okay, so especially this is dihalide. Okay, so remember what is vicinal dihalide, what is geminal dihalide. Assume this structure. If two halogen atoms, assume it will be like this one. If the two halogen atoms are attached to the adjacent carbon, so this is X, this is carbon atom 1, 2, 3 means one X is attached to the carbon 1, another X is attached to the carbon 2. Okay, they are adjacent to each other. Then that is geminal dihalide. If the same halogen is attached to the same atom. Okay, two halogen atoms are attached to the same carbon, then it is vicinal dihalide. So how the question will arise? Give an example for allylic halide. Give an example for benzylic halide. Give an example for any geminal dihalide. This type of questions they arise. Okay, that's why I am giving you the classification. So student, same classification follows for alcohols also. If you just take alcohols here, so what you have to replace? Everything same, based on the nature of carbon atom, based on this sp3 hybridized, sp2 hybridized, same classification is there. You need to replace this hydrogen atom by this OH group. Okay, so in the place of this primary alcohol, this one is secondary alcohol, this one is tertiary alcohol. The explanation is same, students, nothing will change. Explanation remains same as it is. The primary, secondary, tertiary. Why it is called so primary? Because the OH carbon where OH is attached. Same carbon is attached to one R group. Here, why it is called secondary? Because the carbon where OH is attached to the same carbon two R groups are attached. So that is secondary carbon, similarly tertiary. And this is also in the place of allylic halide, we need to take allylic alcohol. Then only the replacement is what? OH. How do you write? The OH is attached to the sp3 hybridized carbon atom, which is further attached to sp2 hybridized carbon atom, and this is an aliphatic compound. So that's why it is allylic alcohol. This one is, of course, benzylic alcohol. The thing is, this X is replaced by this OH. The classification remains the same. Here also, in the place of vinyl, in the place of aryl, just replace alcohol group. Name also replaced by alcohol. This is also OH. This is also OH. Nothing is there. The classification is remains same for haloalkanes, haloarenes, and as well as okay, haloarenes is different. Later I will say. In that there is no classification. In alcohol, in haloalkanes and haloarenes, there is no other classification. Of course, they are directly called as aryl halides and aryl alcohols. In that, only one classification, that is monodietri. Okay, this is the main classification. Next here, so based on the number of halogen atom is replaced by based on the number of OH group. Okay, so I will just replace here. If I take the example of like this is monohydric alcohol. Next here it is CH2 OH, CH2 OH, dihydric alcohol. Okay, next CH3OH, sorry, CH2OH, CHOH, CH2OH. That is trihydric. Means based on the number of halogen atom, they are classified as mono, di, tri. And there is no bisinol, there is no geminol. They are set. Remember, I'll take the example of glucose here. Okay. So here how many alkali groups are there? 1, 2, 3, 4, 5. So this is pentahydric. This is aldehydic. That is glucose. Means so based on the halogen atoms, based on the OH group, they are classified as similarly as halogen, that is mono, di, tri, etc. But the name replaced here by what? Hydric means OH. It gets the prefix hydric, monohydric, dihydric, trihydric. What you are getting? The classification of haloalkanes and the alcohols is same as one. Ready? Molar same. If you know the haloalkane classification, clearly you can answer for alcohol classification. Understood? Okay. So the next one is okay. So the next one is amines. Next one is alcohols. So in the amines also, so based on nature of nitrogen atom, only one classification is there. Okay, so listen in that the primary amine, next secondary amine, and tertiary amine. So these are the derivatives of ammonia. Consider here, I will write the structure of ammonia here. Okay. So listen. Initially, what I explained, what is primary carbon atom? The carbon atom where which is further attached to one R group. Similarly, if the nitrogen is attached to one R group, like R, N, H2 type compound, that is primary ammonia. If these two hydrogens of ammonia is replaced by R group, means R, NH, R. So this is secondary ammonia. If all the hydrogens of this is replaced by R groups, then it is tertiary ammonia. Same. If the carbon is attached to one carbon, primary. If the nitrogen is attached to one carbon, primary. If nitrogen is attached to two carbon, secondary. If carbon is attached to two carbon, secondary. If nitrogen is attached to three carbon, tertiary. Similarly, carbon is attached to three carbon, that is tertiary. In this, another one is there, that is quaternary. The quaternary means same R, N, R compound. This will get plus charge. That is quaternary ammonia. That is quaternary ammonia. But in the main classification, primary, secondary, and tertiary. Only one classification. Are you getting? So this is the classification of amines. There is no arylic, nothing. Okay? Only the primary, secondary, tertiary based on what? The nitrogen. So the next comes is alcohols, ethers and ketones. Ethers and ketones. So students, both the ethers and ketones are classified as symmetrical, and second one is unsymmetrical. I'll give an example. So listen, ether functional group is oxygen. If CH3, CH3 is there. And ketone functional group is CH3, C double bond CH. Assume this is the functional group of ether, this is the functional group of ketone. So on either side of the functional group, if R groups are same, here is also CH3, here is also CH3, here is also CH3, here is also CH3, then they are said to be a symmetrical ethers or symmetrical ketones. This one is symmetrical ether, this one is symmetrical ketone. You may take another one. I am not writing ether, I will write first. So listen, here CH3. CH3, CH, CH3, oxygen, CH, CH3, CH3. Of course, no doubt, this group is also same. This group is also same. We don't bother about which type of R group it is. And we take benzene. Diphenyl ether. On either side of this oxygen atom, the equal number of R groups are there, same type of R groups are there, then it is said to be a symmetrical ether. So if unsymmetrical means, assume the CH3 is there. Oh, CH3, CH2. On either side of the functional group, different atoms are there. Then it is said to be unsymmetrical. Next, we take CH3, CH, CH3, O, and the benzene. They are different. R. CH3O and alone benzene. Of course, the R groups are different. On either side of this functional group, if R groups are different, then it is said to be unsymmetrical ether. Here we are using ether functional group, so it is said to be symmetrical ether and unsymmetrical ether. If we replace this group by C double bond O, there is no need to. Okay, this is the ketonic group. On either side of the ketonic group, same R groups are there. Then it is said to be a symmetrical ketone. Here also, just replace this group by C double bond O. When it is obviously unsymmetrical ketone. Okay, so this is classification of ethers and ketones. We done here what I said, a classification of alcohols and haloarenes are seen. Classification of ethers and ketones are seen. The classification of amines also like primary, secondary, tertiary. We did about all this. So students, the remaining only one is the aldehyde and ketones. So in aldehyde and ketones, there is no any other classification. They simply aldehyde. They are simply ketone. They may be like primary aldehyde, secondary aldehyde, tertiary aldehyde. That depends upon the nature of the aldehyde. But there is no particular classification for them. Okay, so this is all about the different types of classification of aldehydes. So listen, what I explained before is what? Aliphatic compound. If we consider aromatic, only alloalkanes, haloarenes. They are, this is monoalloalkane. This is dialloalkane. This is trialloalkane. Similarly, monohydrate, dihydrate, trihydrate, tetrahydrate, pentahydrate, hexahydrate. Okay, so in this compounds, we can only classify them based on the halogen atom. And I already told you about the benzylic atom. Okay, so that is not involved in that. If this benzene ring is there, only one group, that is aride, aride, aride. Okay, this is also in the right place. Then this is hexahalobenzyne. Alcohols, phenes. So if it is aldehyde, ketone, anything, no doubt in that. If it is aldehyde, benzoyl. If it is carboxylic acid, that is benzoic acid. No, the benzene ring remains same. Only the replaced by the functional group. There is no other further classification. If you take ether, of course this is diphenyl ether. If you take ketone, that is diphenyl ketone. Same. Nothing is different. Diphenyl ketone. Okay. If you take amine, this one is understood? Means in this there is secondary, tertiary only and based on the number of they are classified as mono, di, etc. And for a different functional group, the name follows different. This is haloaline. This one is benzaldehyde, benzoic acid, diphenyl ether, diphenyl ketone, benzene. Different on the based on the function group. So this is all about the classification of the respective organic compounds. What is given previous class. The main they are going to answer is the classification of alcohols. That is very, very important. Classification of alcohols, classification of haloalkanes, haloarenes. Of course, in haloalkanes, haloarenes, there is no 1 marks question, but in alcohols, we must take. But why I am telling this? because the syllabus has been changed. There may be a chance of pricing question in that also. So the classifications are very important, and as well as that NH2. And remember, in the nomenclature of aldehyde, ketone, and carboxylic acid, one is compulsory for examination. That is already fixed question. Okay, so this is about the classification. So this completes the organic chemistry revision regarding functional groups. So another one chapter is there, that is biomolecules. So from tomorrow's class we will discuss with the biomolecules questions. Okay, thank you.